So hello guys, in this video we'll talk about the rest of the Docker networks. So let's get started. So first we will demo this host network. In my previous video I was not able to demo this host network because it only works on a Ubuntu or Linux machine. So I have set a Ubuntu machine here and I have installed Docker in it. So we are going to demo host network using this Ubuntu image. So as we know, in the host network, our container is directly connected to the host. So first let me show you what are these. This is our Ubuntu VM and these are interfaces which are available in our this host. So let's see. Uh, so here you can see the interfaces ENP0S3 or Docker 0. This Docker 0 interface created automatically when we install the Docker, and our host is connected to this interface. It is our host IP address. You can see host IP address and Docker, and our this the interface is connected to the router, and this PC is this Windows PC. So here, when we create a container using the host network, this container is accessible on the host IP address. So let's see this thing in the demo, so it will be more clear to you. First, let me show you the networks. Here are the default networks: bridge, host, or none. So we are going to create a container using the host network. So docker run -itt and mention here the network, that is uh, host, and the name of the container nginx and the image name nginx. So hit enter. So here you can see our container is now running. So first let's inspect this container. Docker inspect nginx. So here you can see the network's host, and here IP address, you can see here it is blank. So with host network, this container will not get any IP address because this container is accessible on our host IP address. So if we check here, it is our host IP address 192.168.1.10, and here if we try to ping this IP address 192.168.1.10, here you can see our nginx server is now running, and also we can access this within our this Windows browser. So here 192.168.1.10. So you can see here it is also accessible from our Windows browser. So we don't need to expose any port while running the container through the host network. So this is about host network, but there is one drawback of this host network. Let me show you. Uh, Here you can see our one nginx container is running on the host network. But here, if I try to create one more container using host network, it won't work. So let's see. Uh, so here you can see the command docker run -itd. Here I'm using the nginx 2 instead of nginx or nginx demo. Enter. So here you can see our container is created, but it won't work. So let me show you. So if we try docker ps, you can see our container is not running. It is our previous container nginx, and if I try to access the logs of this container, docker logs nginx demo, So here you can see the error address already in use. Bind failed, address already in use. So we only use one container using host network. So to solve this issue, MACVLAN come to exist. Let's see what is MACVLAN. So here you can see some applications expect to be directly connected to the physical network. You can use MACVLAN network driver to assign MAC address to each container's virtual network interface. So there are some points to keep in mind. So first, let's see the second one point. Your networking equipment needs to be able to handle promiscuous mode, where one physical interface can be assigned multiple MAC addresses. So with MAC VLAN, our containers directly connected to the router, and they also get the different MAC addresses. So they act as the host to the router. So let's create a MAC VLAN network so this thing will be more clear to you. So here, docker ps, I'm going to remove these containers. So you can see there are default network drivers. So now we have to create a Mac VLAN network. So enter the command docker network create, and here we have to mention the minus minus driver option, and here Mac VLAN, and here also we have to mention the subnet and gateway. You can see here, uh, here is the command driver Mac VLAN and the subnet and the gateway. And here also we have to mention the parent interface. So minus minus subnet, and let's see here. So it is our IP address, and it is our interface. And here the gateway, and here the option, and the parent EMP0S3. And here give any name to the network like MACnet. So all right, click enter. So our network is now created. So now I'm going to create two containers using this MACVLAN network. So and here give the network MACnet and the name of the container, like container 1. And here also we have to give an IP address to this container, IP, and give any IP 1.50, and here the image name. So a container is created. Now let's bash into this container. Docker execute minus it and container 1 and shell. So we are in this container. So if we check the IP address, you can see here the IP address over this container. Now let's create the second container. So docker, so here I am creating a nginx server container 2. So enter docker ps. So here our containers are created. So here now first let's inspect this magnet network. Docker network inspect and the magnet. So here you can see our magnet network, and here is the configuration, the subnet and the gateway. And here are the containers, container 1 and container 2. So here you can see the IP address 50 and 52 and the MAC address. Here you can see they both get the different MAC address 1.132, 134. So as we discussed before, all the containers gets a unique MAC address. So now let's back to our container 1. Here we are in our container 1. Now let's try to ping the container 2 from here. Ping 168.1.52. So here you can see I am able to ping. But if I try to access this Nginx server from my Windows browser, I am not able to access it. So let's see. And 192.168.1.52. So here you can see I'm not able to ping the container from outside, but here I'm able to ping the container because these both containers are on same network magnet, but I am not able to access this container from outside of this network. So how we can solve this? Come to the Docker docs and here see the second point. We have to enable the promiscuous mode to access this container from outside of the network. So how we can enable that? First we have to open the VirtualBox settings and here to the network and advanced, and here promiscuous mode we have to allow all. So okay, after that we have to enable the promiscuous mode from this host network. So let's see how we can do that. First let's see IP address. So here you can see the our interface right now don't have any promiscuous mode. So to enable promiscuous mode, you have to type the command ifconfig and here enter the interface name and enter the promisc and hit enter. So again, if we check the IP address, so our promiscuous mode is now up. So again, if we try to access this container, refresh. So now our container is working. So now I am able to access the container from outside of that network. So now let's try one more Nginx server with the same network and let's see we can access it or not. So docker run -it and the network is MACnet and the IP 1.53 and name give like container 3 and Nginx. So a container is now running. So now let's try to access this IP address 192.168.1.53. So here you can see our this Nginx server is also running. So our both Nginx servers are now running. And if you remember in our host network, we are only able to run only one container, but using MACVLAN, we can solve this issue. But there are some another drawbacks in this MACVLAN network. So first is this, you may unintentionally degrade your network due to IP address exhaustion or to VLAN spread, a situation that occurs you have inappropriately large number of unique MAC addresses in your network. So when we use this MAC VLAN network, and if we create 10 or 15 containers using this network, so there are so many MAC addresses available for our router. And also there is promiscuous mode in which you don't have all control. And one more drawback is there is no DHCP. You have to assign IP address to each of the container. So to solve these issues in the MACVLAN, IPVLAN is there. But before we see IPVLAN, there is one more mode in this MACVLAN network, that is 802.1q trunk mode. So in this mode, we can create sub interfaces. If you specify a parent interface name with a dot included, such as eth.50, Docker interprets that as a sub interface of eth0 and creates a sub interface automatically. So here in the MACVLAN 802 we can create sub interfaces and we can connect different containers to each of the interface. So here you can see it is mentioned use an IPVLAN instead of MACVLAN. So let's see what is IPVLAN. So IPVLAN basically solves the problem of promiscuous mode of MACVLAN. In IPVLAN mode, our containers have different IP addresses, but they use the same host MAC address. Means our containers have the same MAC address as our host. So here you can see the containers, they're connected to our host. They get the different IP address, but they all use the same MAC address as our host. And there is also two modes here, IPVLAN L2 and L3. So L2 is default bridge mode and L3 is layer 3 mode. So first let's create an IPVLAN L2 network and see the working of this network. So now first let's remove the previous stuff. Now here first let's remove this MACVLAN network. For removing a network, there's a command docker network rm and here mention the network name, that is magnet. So our magnet is now removed, network ls. And now let's create a IPVLAN network. So docker network create, and here the driver we have to give here IPVLAN, and also here we have to mention the subnet and gateway and parent interface same as the MACVLAN. This network actually is same as the MACVLAN, but it basically solves the promiscuous problem. We don't have to enable promiscuous mode here in the IPVLAN network. So let's create subnet gateway and the option parent is equal to enp0s3 and the name of our network, give any name like IPNet. So all right, enter. Oh sorry, here I have to give the 8, and here our IPVLAN network is now created. So now let's create a container using this IPVLAN network. So docker run -ipt in detached mode, and here the network IPNet, and name here give nginx demo, and here also we have to give the IP address 192.168.1.60, and here give the image name nginx. So our container is created. So here our container is now running. Now let's try to access this container from outside of this network. Here 192.168.1.60, and here you can see I'm able to access this Nginx server. And also if I turn off the promiscuous mode which is running previously, IP address, so here you can see promiscuous mode is up. So now let's turn off this. So IP link set the interface name and promisc off. So again if we check the IP address, so now you can see here our promiscuous mode is not running now, And here, if I refresh this container, you can see it is working without need of that promiscuous mode. And now one more thing, let's verify the MAC address of the interface and the container. So you can see here the MAC address here of this ANP0S3 is ending with the C39D. And also let's check the MAC address of this container. So if I try here, if I see the ARP table, so you can see the physical address of this IP address is this C39D, and here also C39D. So our container and this interface have the same MAC address as we discussed before. Here our containers use the same MAC address as the our host MAC address. So in this way IPVLAN network works. So next we have the IPVLAN L3 network. So basically in IPVLAN L3 network, we are not connecting our containers to our network like it's a switch, but we are connecting it to our host, like the host is a router. So basically in IPVLAN mode L3, our host turns into a router. So our this host works as a router for these containers. So when we deploy these containers, they make connection to the outside of the container on completely layer 3. Means these containers can talk to anyone outside their own network. That is, container 1 will not able to connect the internet, or not even me, this PC, and I am not able to connect to this container. So for this, we just have to create static routes from our router to these networks. So here you can see here in the documentation L3 mode example. So our this host act as the router, parent interface act as the router. So all containers can ping each other without a router if they share the same parent interface. So basically IPVLAN L3 mode drops all broadcast and multicast traffic. So now our next network is the none network. So we can use none network when we don't want our container to talk to anyone within the network or outside the network. Our container is completely isolated. So let's see this none network here. First, let's remove this container. Here you can see the none network driver is null. So when we create a container using the none network, it will not get any IP address, or it will not connect to anyone within the network or outside the network. So let's see. So let's create a container docker run -itd, and here the network we will give the none network, and the name should be any, like a container 3, and the image basic box. And here if I try to bash into this container 3, and shell, and now you can see here it has only the loopback address, it don't have any IP address. So this container is completely isolated from any of the network. So that's all about the networking. If there is any issue or error while implementing these networks on your system, you can tell me in the comment section. I hope you have enjoyed this video. Thanks for watching.